Welcome to the Nordic Venture Show, your speed date with the hottest Nordic innovations and ventures. In this episode, our venture date is with Canatu, advanced carbon nanotube innovations.
Okay, so you know how it is, you're bombarded with information every single day and it's hard to really understand anything deeply.
Right.
You just kind of skim the surface.
Totally.
And you're left feeling like, do I really get this?
Yeah.
We've all been there. And that's why we're here to help you cut through all that noise.
Exactly.
With this deep dive. Today we're going all in on carbon nanotubes and a company that's doing some really groundbreaking work with them.
A company called Canatu.
Yeah, Canatu. Now, you might not have heard of carbon nanotubes before, but chances are you've already interacted with them in some way without even knowing it. They're becoming that pervasive.
For sure.
And to really break down this topic, we've got a ton of great materials straight from Canatu themselves.
Yeah, their website has been super helpful. They've got all the details about their products and a really cool overview of the company itself.
I was really impressed with how they explain everything.
Me too. And they really get into the nitty-gritty of carbon nanotube technology, like how they're made and why Canatu's is kind of leading the charge.
Yeah, like what makes them so special. So our mission here is to take all that info and distill it down to the most fascinating and important bits.
We want you to come away understanding why carbon nanotubes are causing such a buzz across so many industries.
Right, like what makes them so unique and why should you even care?
It's about understanding the potential they have to change the world as we know it.
Okay, so let's start with the basics. What exactly are carbon nanotubes?
Okay, so picture this. You have a sheet of graphite, you know, the stuff in pencils.
Yeah.
And it's just one atom thick.
Yeah.
That's graphene.
Yeah.
Now imagine you roll that incredibly thin sheet into a tube.
Right.
That's essentially a carbon nanotube. What makes them so special is the way the carbon atoms are bonded.
The bonds are really strong.
Incredibly strong. And that gives these tubes all sorts of unique characteristics.
We're talking way stronger than steel.
Yeah, like 25 times stronger than steel.
25 times. That's mind-blowing.
But here's the thing, they're also super lightweight.
Right, half as dense as aluminum.
Exactly. And not only that, but they're flexible and elastic too. It's kind of hard to believe one material can have so many amazing qualities.
And it doesn't stop there.
No, not even close.
Yeah.
Electrically, they're incredible. They conduct electricity 1,000 times better than copper.
1,000 times better than copper.
And in some ways, they're even better semiconductors than silicon.
So potentially faster and more efficient electronics.
Exactly. Now let's talk about heat. These things can handle temperatures up to 1,500 degrees Celsius.
That's seriously hot.
No kidding. And they conduct heat twice as well as diamond.
Oh.
Plus, they interact with light and other chemicals in some really interesting ways.
So they're kind of like the superheroes of materials.
Pretty much. And in some applications, their value actually surpasses that of diamonds.
More valuable than diamonds. That's saying something. Now, I know there are different types of carbon nanotubes.
Right.
Can you break it down for us?
Sure. There are two main types. Single-walled carbon nanotubes, or SWCNTs, and multi-walled carbon nanotubes, or MWCNTs.
Okay, I'm following you so far.
So an SWCNT is basically that single rolled-up sheet of graphene, just one layer of atoms.
So incredibly thin.
Oh, yeah. Their diameter is something like 50,000 times smaller than a human hair.
That's almost impossible to imagine.
It is pretty mind-boggling. Now, here's where it gets really interesting with SWCNTs. Their electrical behavior depends on something called chirality.
Chirality. That sounds pretty complex.
It can be, but basically it comes down to how the graphene sheet is rolled.
How it's rolled.
Yeah. Imagine you're rolling up a piece of paper with stripes on it.
Okay, I'm with you.
Depending on how you roll it, the stripes on the tube will be arranged differently.
I get it.
It's kind of like that with carbon nanotubes. The specific arrangement of the carbon atoms determines whether the nanotube acts like a metal or a semiconductor.
So chirality is like the secret code of carbon nanotubes?
You could say that, and this code is described by the chiral vector and chiral index. Basically, it's like a set of coordinates that tells you the exact way the sheet is rolled.
So it's all about the structure.
Yes, exactly. Now, MWCNTs are a little easier to visualize. They're basically several of those single-walled tubes nested inside each other.
Like Russian nesting dolls.
Yeah, perfect analogy.
So you've got these amazing building blocks with all these incredible properties, and that's where Canatu comes in.
Right.
What sets them apart in the world of carbon nanotubes?
Canatu is all about creating the most advanced carbon nanotubes possible.
When they say advanced, what does that really mean?
It means they're incredibly focused on quality, reliability, and performance. They're really pushing the boundaries to make sure their nanotubes are top-notch.
They've got to be perfect for all those high-tech applications.
Absolutely. And a big part of that is their unique manufacturing process. They use something called dry deposition.
Dry deposition.
Most companies use liquids to produce carbon nanotubes, but Canatu does it differently.
How so?
They basically create the nanotubes in a reactor and then deposit them onto a surface without using any liquids.
So no messy solutions involved.
Exactly. And this dry process has some major advantages. Well, first of all, it results in much cleaner carbon nanotubes.
That makes sense.
They're also longer and have far fewer defects, which is huge.
Yeah, especially for something like making microchips.
Right. Even the tiniest imperfection can cause a chip to fail.
So these defect-free nanotubes are crucial for those kinds of applications.
Absolutely. And on top of that, Canatu is really good at customizing their nanotubes for specific uses.
So it's not just a one-size-fits-all material?
Nope. They can fine-tune it to perform perfectly in all sorts of different situations.
That level of control is pretty impressive. Now let's talk about some of the real-world applications where Canatu's carbon nanotubes are making a big impact. What are some of the key industries?
Well, they're really focused on the semiconductor and automotive industries right now.
Those are two huge fields.
They are. And they're also doing some exciting work in medical diagnostics.
Let's start with semiconductors, since those are the brains behind pretty much all our technology.
Right.
How are Canatu's nanotubes changing the game there?
Well, they're playing a big role in something called EUV lithography.
EUV lithography.
This is the cutting edge of microchip manufacturing. It allows us to create chips with features that are smaller than the wavelength of ultraviolet light.
That's unbelievably tiny.
It is. And Canatu's carbon nanotubes are used to make these incredibly thin and strong membranes.
Membranes, what do they do?
They're used in EUV pellicles, which are basically like protective films for the photomasks used to print those tiny circuits onto silicon wafers.
So they're like the bodyguards of microchip manufacturing.
Pretty much.
Yeah.
They protect the photomasks from even the tiniest speck of dust.
Which could ruin the whole chip.
Exactly. Canatu's nanotubes are also used in debris filters and optical filters in these lithography machines.
So they're involved in several different stages of the process.
Yeah, there was a big article about it last year, all about how carbon nanotubes are poised to revolutionize the semiconductor industry.
So we're talking about potentially faster and more powerful electronics.
Right.
All thanks to these tiny little tubes.
It's pretty amazing when you think about it.
Okay, so let's shift gears to the automotive industry. Obviously, self-driving cars are a huge trend right now.
Yeah, that's a major area of focus for Canatu.
How are they contributing to that?
Well, one of their key innovations is CNT film heaters.
What are those for?
They're used to de-ice and defog the lenses of LiDAR and camera sensors.
Which are essential for self-driving cars.
Right. Those sensors are basically the eyes and ears of the car.
They need to be able to see clearly no matter what.
Exactly. Especially if the car is driving itself.
So these heaters help ensure the sensors are working properly even in bad weather.
Yeah. Rain, snow, fog, you name it.
That's a big deal for safety and reliability.
For sure. And they're also working on touch sensors for cars.
Oh, interesting.
Yeah, they're using CNT films to create touch-sensitive surfaces that can be integrated into all sorts of parts of the car.
So like dashboards and door panels.
Yeah, things like that. It gives car designers a lot more freedom to create these really intuitive and seamless interfaces.
That sounds really cool.
It is. It's all about creating a better user experience.
Now, we've talked about semiconductors and automotive. Let's touch on medical diagnostics. I understand Canatu is doing something with opioid detection.
Yeah, they're developing these really sensitive sensors that can measure the concentration of opioids in blood.
How do they do that?
They're using the unique electrochemical properties of carbon nanotubes.
So these sensors could be used to help diagnose and monitor opioid use.
Exactly. The goal is to create these really affordable point-of-care diagnostic tools that are easy to use.
So something that could be used in a doctor's office or even at home.
Right. It could really make a difference in addressing the opioid crisis.
That's a really powerful application.
It is. It shows how Canatu is thinking beyond just the materials themselves. They're thinking about how to use those materials to solve real-world problems.
They're not just scientists, they're problem solvers.
Yeah, for sure. Now, in terms of their business model, they have kind of a two-pronged approach.
What do you mean?
Well, on one hand, they develop and manufacture their own advanced CNT materials and products,
Okay.
but they also sell their CNT reactors and license their technology to other companies.
So they're kind of empowering other companies to create their own CNT-based solutions.
Right. It's all about collaboration.
And speaking of collaboration, they seem to be big on partnering with other leading companies.
Oh, yeah. They call them forerunner companies.
What's the idea behind that?
The idea is to work with companies that are really pushing the envelope in their respective fields, and together they try to create these groundbreaking innovations.
They're really trying to drive progress.
Exactly. They have a really strong partnership with Denso, for example.
Denso.
Right?
That's a big automotive supplier, right?
Yeah, one of the biggest. They're working together to develop high-performance reactors for manufacturing CNT films.
So they're basically scaling up production.
Right. They're aiming to triple Canatu's current production capacity.
That's a huge increase. It really shows how much demand there is for this technology.
It does. Now, another important aspect of Canatu's vision is sustainability.
They're thinking about the environmental impact.
Oh, definitely. They see carbon nanotubes as a much more sustainable alternative to a lot of traditional materials.
Because they're made of carbon.
Right, which aligns really well with the idea of a circular economy.
So they're thinking long term.
Absolutely. And speaking of the future, they're also exploring some really exciting possibilities beyond what we've already talked about.
Like what?
Well, one big area of research is using carbon nanotubes to replace silicon in transistors.
Really?
Yeah. Imagine even smaller, faster, and more energy-efficient electronics.
That would be a game changer.
It would, and they're also looking into using CNTs as optical filters for EUV light and X-rays.
What would that be used for?
It could have huge implications for telescopes and medical imaging.
So potentially better telescopes and medical devices?
Exactly. They've actually launched a whole program called Carbon Age to really dive deep into these possibilities.
And it's gotten a lot of funding?
Yeah, they received 10 million euros from Business Finland.
That's serious investment. And they also won an award recently, right?
Yeah, the 2024 Listing Award.
It seems like they're getting a lot of recognition for their work.
They are. They're definitely a company to watch.
So to recap, we've talked about how carbon nanotubes have this incredible combination of strength, conductivity, and versatility.
Right.
And Canatu is really at the forefront of developing and manufacturing these advanced materials.
They've got this unique process that lets them create incredibly high-quality nanotubes that can be customized for all sorts of different applications.
And we're seeing the impact of their work in semiconductors, automotive, and even healthcare.
It's pretty mind-blowing to think about.
It is. Here's the thing, even if you don't know anything about carbon nanotubes, chances are they're already influencing your life in some way.
And that influence is only going to grow in the future.
Which brings us to our final thought for today.
Given everything we've learned about the potential of carbon nanotubes, what other seemingly impossible problems might they help us solve?
Yeah, what other technological barriers could we break down with a material this powerful and versatile?
It's something to think about. The future is full of possibilities.
Thanks for joining us for this deep dive.
It's been a pleasure.
We'll see you next time.
Until then, keep exploring.
Thanks for listening to the Nordic Venture Show. Don't forget to subscribe and stay tuned for more stories of innovation from the Nordics.